Hello everyone, I hope you are doing well. So today we are discussing a important topic from our physical chemistry, that is oxidation state, right? This is important topic, will impact our some of the other important topics like you can say balancing of redox reaction, or you can say N factor, or you can say law of gram equivalence, right? So we will learn how to find oxidation state. Basically there are two methods if you want to find oxidation state, right? One method you know by the formula, like you know some elements oxidation state, and you have to find for one of the element for which we don't know the oxidation state. So we apply sum of the oxidation states of all the atoms equals to the charge present on the molecule. If it is neutral molecule we put 0, and if it is ion, so we put the charge, right? But now today we are discussing how to find oxidation state using structure, right? It will have its own benefit. Some questions you cannot do without like you cannot do by the formula. You need structure in these. Which type of questions we will discuss now, right? So let us start. The first thing is what is the meaning of oxidation state? Especially we are dealing with structure. So oxidation state is the apparent charge, right? It is the apparent charge which will appear on the atom when you will break all of its bonds using electronegativity, right? We will see what are the rules, but for basic thing if I tell you, when you break a bond, so give +1 to the more electropositive element, or you can say less electronegative element, and give -1 to the more electronegative element, right? Clear? We will see the rules. Let us see the first one basic example which you can understand easily, right? So we are taking example, imagine we are having here CCl4, right? We are having CCl4. So how we can do this question? How we can find the oxidation state of carbon using structure, right? If I know the structure, this is carbon here, this is chlorine here, chlorine and chlorine, right? So I want to break the bonds. I will break all the bonds of carbon and I will give +1 -1 according to the electronegativity of elements, right? Like here, if I am breaking the bond, imagine I am breaking this bond. So this bond you break, you will give -1 to chlorine and +1 to carbon. Why? Because carbon is less electronegative and chlorine is more electronegative, right? Similarly, I will break this bond also. So -1 here, again +1, from here -1, again +1, from here -1 and again +1. So I break all the carbon bonds, and from every bond it got +1, +1, +1, right? So in this way you see carbon is getting what oxidation state? It is getting +4, right? It is one of the simplest example, right? We can have one more example, right? We can see if I am having sulfuric acid. In sulfuric acid I want to find oxidation state of sulfur here. So how we can find this using structure, right? So if you know the sulfuric acid structure is S double bond O, S double bond O, OH. Here we have OH, right? Now I want to break all the bonds of sulfur using electronegativity, fine. If we want to break it, so you will see I am breaking this bond, double bond I am breaking. So oxygen will get which charge? -2, sulfur will get which charge? +2. Here I am breaking two bonds, -2, +2. Here I am breaking one bond, -1, +1. Here I am breaking one bond, so oxygen get -1, and here we got +2, sorry, +1, right? So overall, if you see, I have broken all the bonds of sulfur, right? From this bond +2, +2, +1, +1. So overall, sulfur will get how much charge if I will break all the bonds? +6, right? Definitely, it is more easy to find oxidation state by the formula, but in some compounds you cannot find using the formula, you need structure. That's why this method is required, right? I will tell you which questions you cannot solve by the formula, right? So this is it, basic thing, okay? So if we try to understand the rules, what are the rules? Basic rules, right? How to find oxidation state using structure. So oxidation state using structure, I am going rule by rule, right? So what is the first rule? If you go for rule number 1, what this rule is saying, as I said just now, if I am breaking bond between two atoms in which one is more electronegative and one is less electronegative, so give +1 to less electronegative and give -1 to more electronegative, right? So here we have, I am breaking this bond, A and B bond, and I am mentioning here clearly A is a less electronegative atom here, right? And B here is more electronegative, right? And if I am breaking this bond, you will see I am breaking the bond. So more electronegative atom will get minus charge, -1 if I will break this bond, and A will get +1 if we will break this bond, right? First rule. There are two different atoms we are breaking according to electronegativity, right? Rule number 2. Here we have, if we have same atoms, if atoms are same, I am saying here, imagine bond is between A and A. A, definitely both have same electronegativity beta, both have same electronegativity. Sometime even same atom can have different hybridization and different electronegativity. Even if we break bond between same atom, it can also have charge sometime. But here I am saying both atoms have same hybridization, complete same electronegativity. So in such cases, you will see, you will break the bond and both will get 0, 0. In this, none of the atom is getting +1 or -1. In most of the cases, when you break bond between same atom, you just give 0, 0 to both. Very rarely we have some examples where we have to give charges, okay, in case of same atom also, okay, we will see that. Now next thing is rule 3. This is specially for coordinate bond. This is specially for coordinate bond. So if two atoms have a coordinate bond in between and we are breaking this bond, we have some different rules here. So first of all, imagine here we have C and D. C and D is having a coordinate bond, and C here is a less electronegative atom, and D here is a more electronegative atom, right? C, less electronegative atom, is using its 2 electrons to make bond with D. As both the electrons are given by C, so C is here making coordinate bond, giving both of its electrons, and D is just making bond, is not giving any electron to make the bond, right? In such case, when we will break this bond, we are breaking a coordinate bond here. In such case, you will see this atom, less electronegative atom, will get +2 charge, and this will get how much charge? -2 charge. I am breaking single bond. This is a coordinate bond. But what is special here? In this coordinate bond, less electronegative atom is giving both the electrons in this coordinate bond, right? If I take the real example here, you can see, if I am having a bond, imagine between you can say we can have here like N and O. This bond is between N and O, coordinate bond. N is giving both the electrons here. So in this case, you will see I am breaking this single bond here, but in such case nitrogen will get +2, oxygen get how much? -2, right? Coordinate bond, special case. And next beta, if you go for rule number 4, again it is for coordinate bond, but little change this time. This is a coordinate bond, right? This time imagine E, we have atom E. E is making coordinate bond with F, but this time E, the atom which is giving both the electrons in the coordinate bond is more electronegative, whereas it is what? Less electronegative. So when bond is formed between more electronegative, less electronegative, and electrons are given by more electronegative. So if you break this type of coordinate bond, so you will give 0 0 to both. You will not give any charge to any one of these. You will get 0 0. We will see the real example. You will understand this. Clear? So there are 4 rules you can say. If you are breaking bond between two different atoms, simple covalent bond, break it, give +1 to less electronegative, -1 to more electronegative. If bond is between same atom, A, carbon, this way, break the bond, 0 0. Third case, coordinate bond, less electronegative atom giving to more electronegative atom. Break the bond, +2 for less En, -2 for more En atom, right? And reverse way, when more En giving to less En. In such case, you will say 0 for both the atoms. If I take the real example for this one, you can take here, imagine we have nitrogen and here we have coordinate bond with carbon. More En, less En, and a coordinate bond we are having. You will see, you break the bond. What we got here? We got 0 and 0. Nothing we will give, no charges we will give to atoms when we are breaking this bond, right? Clear? Okay. So now we can take some real example for these, right? Let us see how we can find. We can take some examples here, right? So first of example, I am saying like we are having here H4P2O6. I want to ask here, what is the oxidation state of phosphorus here, right? Similarly, if I take, okay, first we are solving this. It is our hypophosphoric acid, very important structure from inorganic point of view also. Right? So if we break the bonds of phosphorus and try to get its oxidation state, right? So here I am breaking two bonds. Two bonds give it -2, +2. From this bond -1, +1. From this bond -1, +1. So from here you check, phosphorus is getting with how much? Phosphorus is getting +4. Phosphorus getting +4, right? Similarly, if you break this phosphorus, and remember this bond is between same phosphorus, same electronegativity, same hybridization even. So when you break this bond, nothing you will get, 0 0. So from these bonds it is getting +4, from this bond getting 0. Similarly, if you are breaking this bond, total 4 bond I am breaking from here, and from here phosphorus getting again +4. So both the phosphorus are having +4 oxidation state. Okay, PP bond when I am breaking, I am giving both of them 0 0 because it is between the same atom, right? Clear? Okay, good. Now next thing we are having here, we can have H3PO4. We can have one more structure here, H3PO4. Okay, we want to find for phosphorus. Here we have P double bond O, it's OH and OH, right? If we have the structure, we can easily find, right? Tell me, what will come? If I am breaking the bond here, you will see double bond breaking, -2, +2. Single bond, -1, +1. Again single bond, -1, +1. Again single bond, -1, +1. +2, +1, +1, +1. How much coming? +5. Very good. Right answer. We are getting +5. Right? Okay. We can take 1, 2 more examples. Imagine we are having here HCN. In HCN, I want to find for carbon. Okay, and you can find for every atom in this way. Okay, HCN beta. If we have HCN here, what it is? H here, C, single bond N. HCN structure is this one, and all bonds here are just simple covalent bonds. There is nothing coordinate, right? Carbon can make 4 bonds and nitrogen can make simply 3 bonds. Nitrogen's 4th bond is found to be coordinate bond, right? But here all are simple bond. There is no coordinate bond, right? So if we try to break all the bonds, I am breaking nitrogen's 3 bond here. So from here nitrogen getting how much charge? -3, because nitrogen is more electronegative, and carbon will get how much? +3, right? Because of it is less electronegative. When I am breaking this bond, out of carbon hydrogen is little bit less electronegative. So you can say hydrogen getting +1 and carbon getting how much? -1. So carbon getting +3 from these bonds and -1 from this bond. So overall if you check bache, overall carbon is getting how much? +2. Carbon getting +2 and nitrogen how much? -3. So you can find this way every individual atom's oxidation state. And as I said, here all bonds are only simple. They are just covalent bond, no coordinate bond, no use of rule number 3 and rule number 4, just 1 and 2. Fine. Okay. Next thing, we can take one more example here. Imagine we are taking HNC, isocyanide. It is HNC. In this case, we have to be little careful. Okay, I am drawing a structure HNC. HNC. Nitrogen making 4 bonds. A neutral nitrogen atom is making 4 bonds. So be careful. One of the bond is definitely a coordinate bond. One of the bond here is a coordinate bond. Right? Now, if you go step by step again, you are moving step by step. So you will see, if I am breaking this bond, this one bond is giving me here what? +1, -1. I am breaking one bond, less En got +1, more En got -1, right? I am breaking here 2 more bonds here. We have 2 bonds. Normal covalent bonds are there. Okay? So these will get what here? -2, +2. Nitrogen got -2 and carbon got +2. But the third bond, if you check, third bond is coordinate bond. So please check carefully. Third bond is a coordinate bond and less En, less electronegative atom is giving both the electrons in this coordinate bond. Right? Sorry, nitrogen is more electronegative and both the electrons are given by what? Nitrogen. So in such case, we will apply rule number 4. And when we break this type of coordinate bond, no atom will get any charge. Both will get 0, 0. I am saying once again, if I am breaking a coordinate bond, in that case, if in coordinate bond, more electronegative atom is giving both the electrons, then in that breaking of bond, both will get 0 and 0. That's it. Clear? So in this way, if you check, what is coming? Nitrogen getting overall -3. Hydrogen getting +1 and carbon getting +2. Fine, clear? I hope you are clear how to use these all 4 rules. Okay, I am taking one more example, a very important example. Once more, you see we are having HNO3. We are having HNO3. If I draw the structure for HNO3, you will see we are having N double bond O. Here we have a coordinate bond O, and here we have you can say OH, HNO3. This is a case where we have a coordinate bond in which less electronegative atom is giving both the electrons in this coordinate bond, right? So if I break this bond, you will see from here nitrogen got -2, it is get +2. From this bond, oxygen got -1, nitrogen got +1. And this coordinate bond, when I will break, so this oxygen will get which one? -2, and our nitrogen will got +2. Rule number 3, in a coordinate bond where less electronegative atom is giving both the electrons in a coordinate bond here, right? So less En will get +2, more En get -2. So nitrogen overall getting +5 oxidation state. +5 oxidation state. Clear? So we have seen all the 4 rules, how to use it. Okay. Now one question come to our mind, sir, these questions we can solve even by the formula. We can apply the formula and we can get it even in less time. So I told you there are some questions which you cannot do without the structure. What are these? If I tell you, so we will see. Look at this. So what are the benefits of this method? Okay. So what happens sometime in some questions you will see, sometimes they ask find oxidation state of individual atom, right? Formula always give us average only. Imagine I have 3 phosphorus in my molecule, so formula will apply the average. For all phosphorus I will use 3x and I will solve it. So I will get only average of all 3 phosphorus oxidation states. But structure can tell you individual, this phosphorus have how much oxidation state, this how much, this how much. This can be asked, right? In NEET exam 2 years back they asked this question. I will show you the question, right? Second benefit is to understand the concepts in peroxide linkage molecules. Okay, it will help us. So help to find oxidation state in peroxy compounds which have peroxy linkage. If you directly apply the formula, you will get wrong answer, because you don't know in your given molecule how many oxygens is having peroxide linkage. So if you apply the formula, you will put oxidation state of every oxygen as -2 only. But if you have structure, then you know how many oxygens are in peroxide linkage, so we have to use -1 for these oxygens, not -2. Okay, so these 2 special questions are these questions in which we use structure only. Without structure you cannot give the right answer. Fine. I am taking example. Example is, I am saying the NEET question here just from NCERT, Br3O8. Now I want oxidation state of every bromine individually. I don't want average. They are asking individual. Definitely I should know the structure here. Br3O8. If I am saying this is Br here, this is Br here, this is Br. And good thing is they never ask in the NEET exam, they never ask out of NCERT. So some structure which are very common, they ask those only, right? So I want for every single bromine individually, right? What we can do? Now break the bonds of bromine. I am breaking 2 bonds from here, -2 + 2, -2 + 2. You can say -2 + 2, -2 + 2, -2 + 2. So bromine got how much? +6. And remember, this bond is between same atom, bromine. So same atom bond you are breaking, then you will go how much? 0, 0, right? Similarly here, I am breaking this bond, 2, 2, -2 here, -2 here. My bromine got overall +4, because this bond is giving 0, 0. This bond also how much? 0, 0. Now from here, I will break this -2, and how much? -2. So this bromine got +6. So if you go for individual bromine, you can see beta, first bromine got +6, other bromine got +4, and other bromine got how much? +6. So +6, +4, +6. If you apply the formula, then you will see formula will directly give answer 16/3, which is average. How? 6 + 4 + 6, 16. Total how many bromines? 3 bromine. So 16/3. But if they ask individual atom, this bromine how much, this how much, this how much, then I need structure. Clear? Again, Again, one more question from just NCERT. We are having here C3O2, carbon suboxide, right? So oxygen, carbon here, carbon here, carbon here, oxygen here. Clear? So in this case, if you see, we are applying the formula again, sorry, the structure again, method, rules. Here I am breaking. If I will break this one, I got -2. My carbon got +2. This bonds, these two bonds are between same atoms. So two bonds I am breaking, but both are between same atom, 0, 0. Here, 0, 0. Here, two bonds I am breaking, oxygen got -2, carbon got +2. Right? So in this case, you see, this carbon, if I go particularly every carbon, first carbon +2, next carbon 0, next carbon again +2. Right? So again we can get individual atom. Average, if you check, formula will give you 2 + 0 + 2, 4/3. Average oxygen state is how much? 4/3. But just by the formula you can never tell that one of the carbon is present in 0 oxygen state. Clear? So that's how you cannot give complete overall review, overall explanation for individual atom by just formula. You need structure. Clear? One more thing I will take here. Clear? Now you can take this one. If you have here this one, sulfur, double bond O here, it's OH. Here we have sulfur, double bond O, it is just lone pair here and OH. So we have this structure again. If you break the bonds again, it is pyrosulfurous acid, right? If you break the bonds, -2 + 2, -2 + 2, -1 + 1, 0, 0. So this sulfur is coming in +5, right? Whereas you break this -2 + 2, -1 + 1. So this sulfur is coming in +3. Right? If I go individually, so one sulfur is coming where? In +5, and one sulfur coming where? In +3. Again, formula will give you just average, that is +4. Okay, so this way we can get individual atom oxygen state. First benefit. The other benefit of this concept using structure is to find the oxidation state in which formula will fail. Formula give you wrong answer, especially in peroxide questions, right? So we can see better. For example, I am having some examples here which have peroxide linkage. First one I can say H2SO5. Peroxy, you can say it is peroxy monosulfuric acid, or you can say caro acid, right? I want to find for sulfur. If you apply the formula here, formula will give you oxygen state almost you can say +8, which is definitely wrong. Sulfur cannot have oxidation state more than +6. So formula is giving us wrong. Why? I am telling once again, I am showing here. If I apply formula 2 × 1 for hydrogen, sulfur is X, and 5 × -2 for oxygen, which we apply in general because we don't know which oxygen is -2 or which oxygen -1. So by the formula if we try, it is coming +8. Definitely it is wrong answer because sulfur can show maximum how much? +6. That's why I need structure. It is peroxy monosulfuric acid. You will see this is a structure. This is our structure, right? In this case you can see, break the bonds step by step and you will get your answer. Here if I am breaking two bonds, -2 sulfur got +2, again -2 sulfur got +2, from here -1 sulfur got +1, from here -1 sulfur got +1. So you can see clearly sulfur is +6 only. Structure giving you very much clarity. What is the wrong in formula? in structure you will see, because of peroxide linkage, both oxygen, these oxygens are present in -1 oxygen state. But in the formula I am putting all oxygens as -2, which is a wrong thing. But structure is telling us that these two oxygens are present in -1, not -2, right? So structure is telling that way, right? Next I can take same way. If we take here H2 S2O8, peroxy disulfuric acid, or you can say Marshall acid. If you apply the formula, so 2 into 1, sulfur is 2x, and here we have 8 minus 2 equals to 0. If we solve these things, x coming plus 7. Formula is giving us that sulfur is getting plus 7 oxygen state. But again, it is wrong. Sulfur can't have more than plus 6, right? So we will go for structure. Here we have structure S double bond O, S double bond O. It's OH. Here we have O, peroxide linkage. S double bond O here, O, and it is OH. It is a structure. Now we go step by step. I am breaking this bond, more electronegativity, how much? -2, +2, -2, +2, -1, +1, -1, +1. So sulfur, if you check beta, overall sulfur is getting plus 6 oxygen state. Okay, here also -2, +2, -2, +2, -1, +1, -1, +1. This sulfur got how much? Plus 6. I will not break all the bonds because I need oxidation state of sulfur. So I will break all the bonds of sulfur only. Don't think that sir sulfur oxygen is how much. If I break this bond, oxygen get only -1. So these two oxygens are present in -1 oxygen state. They are not -2. That's why formula is giving us a wrong answer, right? So I will take one more example where formula give us wrong answer, and very important from NCERT, CRO5. Formula give us x into 5 into -2 equals to 0, and x coming plus 10. Again this is wrong, right? This is wrong. Why it is giving wrong? Again peroxide linkage. Clear? So we can see bache, structure, very famous structure, butterfly structure. This is our peroxide linkage, right? Okay, now you break all the bonds step by step. I want to find oxidation state of chromium, so focus on chromium. I will break all the bonds of chromium. I will not waste to break all the remaining bonds. I will break bonds of chromium. So chromium I am breaking here. If I break from here, 2 bonds I am breaking, -2, +2. 1 bond, -1, chromium got +1. From here, -1, +1. From here, -1, +1. From here, -1, +1. If you see, chromium getting how much overall? +6. Right? Clear? So this is it, how we find oxidation state using structures. And this is especially useful for 2 type of question I told. For those where we need to find oxidation state of individual atom, and to find oxidation state of elements in those compounds which have peroxide linkage, where formula gives us wrong answer, right? Okay bache, I hope this video will benefit you. Thank you, bye.